All right, and we still got 48 minutes, so we're in real good shape here. Again, I'm purposely leaving the 4 forces on the airplane in these lessons just to get the kids to think about what's going on with the aircraft. And what we're going to do on this is when we talk about lift, that's the force that goes in the vertical. It's created on the wing, and it's created by a difference of air pressure. So this is kind of a fun lab because we're going to do things to show them, well, what impacts the amount of lift we're going to get. And what we're really trying to get the kids to see is it's not only going to be airspeed, it's going to be angle of attack. So it's going to be airspeed as well as angle of attack. We'll get to angle of incidence in a moment here. But what we will do in the lab is we'll have the kids, and I'm going to bounce out here now, go into X-plane. Bear with me a second. Is we're going to have the kids come in fly final. When they say fly final, that means you're coming into the airport. I'm going to pull this up right now. You can see here we get the deer running through there. And of course, I don't have my disc on there. All right, here we go. So I go to settings, quick flight setup. I'm going to select final. Don't go to the airport. It puts you back on the ground. Let me say that again. Do final approach and exit out. If you click on airport, you'll end up on the airport. But we want to be in the air. There we are. Put the square in there. Let me pause it in a second. All right. I'm going to hit the letter A. There's our airplane. Oh, no. Some of our pilots are listening. Has anybody flown into Innsbruck yet? So there it is. Right here, these green lines are the lift vectors. Notice these green lines going in that negative direction. So this is the pot. We're going to define that as positive. This is negative. So it acts like a teeter-totter. But we're going to define lift by, in the beginning, having the airplane stall it, which is really kind of fun. All right? And we're going to also go ahead and get our settings in there. So we've got our airplane. We're going to fly. We'll go up to settings real quick. And it calls for on our settings, really just airspeed and lift. So 3, we don't really need distance traveled. We're already in the air, so we're not going to worry about landing gear. We are going to see how much lift we get off the wings. So there you are. We've got right up here, airspeed, the amount of lift. And what the kids are going to do in this is they're going to watch what happens on the airplane. We're going to unpause this. I normally don't let them fly in I call it God mode. Just that little cursor right there. Just pretend that was in the front of the cockpit. So like right there it is. We're doing the same thing with the cursor, only we're going to have it with the airplane. Now, of course, I jump out, it immediately starts doing it. But watch is my airspeed. I'm not changing my throttle, so look what my airspeed starts to do. Boom. I just fell out of the sky. My amount of lift is not enough to hold the airplane up out of the sky. And you can look over there and see the airspeed. You can look at the lift on that. And so you're showing the kids basically what a stall is. You're doing the equivalent of showing them what lift is by showing them what it's not. All right? So then, as they do that, they're looking at the lift vectors. And you can have... they can have a lot of fun with this. Go ahead and let them stall it a couple times. And they really need to see it. If they fly it from the inside, you don't see much other than just a lot of blue sky. You see your airspeed's all wrong. All right, and you're at a stall speed. So then, after we unpause it that way, if they do this and they crash, all right, I can pull up. Oh, look at that. Look what my lift did. Again, climbing up, climbing up. Look what my lift's doing. It's just stalled. One wing tends to stall before the other wing does. In a real airplane, there would be plenty of warnings to the pilot. The pilot would feel it. She or he would feel it in their wings. There's a warning goes off. In the older planes, the newer planes are very efficient. Therefore, there's a little bit less of a warning. Okay, let me go ahead and unpause this real quick. Let's go ahead up here. When I just want to crash, I'll just go back to quick flight setup. I'll go final approach, 3 nautical miles. Boom, here I am again. All right, now, going to go ahead and let it go down. It's climbing, climbing. All right, now if I let it go just straight down, notice the airspeed's going up. If you watch what my airspeed do, it's going up, but it's really not getting that much lift. It's once I also had a little bit of angle attack. See how much more lift I get? It's tremendous. One fun thing you can do with the kids if in class, especially if you've just done lesson 1 and 2 and it's really kind of working at it, one thing to do with kids they really like is see if you can get the highest lift value. All right? Now, obviously in a real airplane, you can exceed the airspeed. And doing this could cause the plane to fall, structures to fail. But this is a great thing about a virtual aircraft. In case you're wondering what the red to green is, the red is the drag. We're going to talk a little bit about that. But just kind of, I want you to get out of this. The red is the drag. The lift is a horizontal lift vector. It's a yellow. We're pretty much going to ignore that. But there's your green lift. And in case you're wondering, that must mean that the more lift you get is indeed you get more drag, and that is true. That's called induced drag, and we're going to come back to that down the road here. Okay? Any questions about this right now? All right. All right, the next thing we're going to do, as we pause this, is as the kids go ahead and do that, they're going to find out, they're going to go ahead and experiment with it. So the question they're going to start to ask is, well, what about that angle of it? And why don't I always have the plane pulled back? Let me describe it that way. Why am I not always sitting in the seat horizontal? One of your kids might ask that. So let's find out. Let me get out of X-plane here. And that's where we get into this angle of incidence. They'll discover the angle of attack and airspeed are both very powerful. Then you can talk about, for those kids you want to share this with, the angle of incidence is an angle of attack built into the wing. It's just a few degrees, but it always gives them an angle of attack. Otherwise, the pilots would slightly have to pull back all the time. All right? And so there's 2 other things. I don't have the screen up here on this. There's 2 things. Well, what causes lift? There's 2 things. This difference in air pressure, for years it was Bernoulli's principle. Bernoulli's principle is, hey, you move a gas faster and faster, the air pressure decreases. And we do that over a curved surface. And we have a nice graphic in the drawings and the handout to show that. But that's not the only reason. There's been a pretty big debate in the last decade or 2 of if that's the only thing going on there. And what about symmetrical wings? And there's some other issues. So the other explanation for lift, and there's actually some more, but the next one is the Newton's third law. And basically the wing it's also called skipping stone, where the air underneath the wing is hitting the wing and then bouncing down, which is resultant vector causes the wing to go up. So for in this class, and for the way we're teaching, we're saying lift is both Bernoulli's principle and Newton's third law. And if you read any old books, they're all only going to talk about Bernoulli's principle. All right? Now, I just jumped ahead. Any questions about lift? All right? The next one we're going to talk about is drag. That's a force that goes in the opposite of flight direction. And the way I always explain it to the kids is just if you've been at the beach or been at a pool and you can run along the pool nice and easy. Get in the water and try to run as fast as you were running outside the pool. Or you run along the beach and then try running in the water at waist depth. That's drag, resistance of movement. All right? And most of the time, drag is something we're constantly fighting with. And in a minute, we'll talk about the two types of drag. All right? But there is a time that we want drag. We want to slow the airplane down. And this lesson 4 is leading to lesson 5, and that's where we're going to land. So there's my hint. We want to slow the airplane down. What most people don't realize is we've designed these airplanes to fly so well, they really don't want to land. If you took once you maintain level flight on most of these planes, you let go of it, it'd just fly. Remember a few years ago, someone fell asleep in his airplane and ended up over the Atlantic Ocean and had to ditch it at sea, but the plane just flew just fine. Well, I, for one, am happy that the airplanes want to fly. However, when you try to land, that can be a little bit of a challenge. So what we want to do is do things to slow the airplane down, but we would also like to be able to increase lift. So that way we can fly as slow as possible. And the really neat piece of equipment on an airplane that does both that, is we want it to slow down, add some drag, but flaps also add lift. Because if you just added drag, if you just stick your hand out of the airplane, that's not going to, sticking your hand in the airplane ain't going to slow you down very much, but also it's slowing you down, and if you don't compensate, you're also going to lose lift. Because we just learned in the lesson before that lift's fundamentally due to airspeed and angle of attack. Those that play a big role in it. So here we are. We've got flaps. And because they increase basically the wing surface of the plane by projecting backwards, whenever you're on a jet airplane, you're coming in to land, you hear that really loud noise. It's probably the flaps coming out. It gets close to the ground. It might be also air brakes too. But those are in the front of the wing. The air brakes tend to be on the front of the airfoil, the front of the wing. Airfoil is the shape of the wing. And the flaps extend out from there. And they do two things. They increase drag, which is going to slow you down, and they increase lift, so you can fly at this slower speed. So that's what makes that pretty great. So in this lesson, they're going to get to do a lot of just flying with both. In the beginning, they fly a new airplane, and they're going to fly with flaps. They're also going to fly with landing gear. So let's go ahead and take a quick look at that lesson. Go over here.